Another wonderful edition coming right at you where we review calculus concepts via Mrs. Fox's Patio Productions. And if you're wondering if I'm wearing the same shirt as I did in the previous video, I am. Can you believe that? I mean, seriously, the epitome of laziness. Actually, I'm just filming two things in one day because of my rain, and then I can't do patio productions. I mean, seriously, we can't have that. Okay, so here we go. Let's get right to it. We are going to do Unit 7 concepts, okay? So in Unit 6, we started doing things with integrals. And so now we're going to do that very same thing again. And so let's go ahead and jump right into our Unit 7 topics. Okay. Hopefully you're keeping up with your FRQs. You're making sure everything is golden. You're practicing them. You're writing down things that are weak for you that you need to practice, all that good stuff. So Unit 7 is about differential equations and like solving those differential equations, right? Like so fun. And so let's just dive right in and think about what things that College Board has put in their Unit 7, okay? So one of the things that they're going to do is they're going to model different situations with a differential equation. Guys, remember all a differential equation is, it's just an equation, and basically it says, let's get some writing here, it basically has like a dy and then a dx as part of its equation, and then you have to solve that a particular way, okay? Sometimes when we solve these, we have to remember that it may be in general, like a general solution. And so you may have to do like a plus C on your guys. That's always always very important. We talked about the idea with these differential equations of slope fields, okay? So there's kind of like two topics that they do with slope fields. Sometimes you build your own slope field, right? Where they give you some sort of, again, like some sort of a dy dx equation. You plug in the coordinates here, like these lattice points is what they usually call them. And maybe you get little, you get numbers and then you try to do little slopes. So maybe you get like a little slope of 1 and you try to draw a little segment that's 1, or a slope of 0, or maybe like a slope of -1/2. So it's kind of shallow, but it's going negatively, something of that nature. But then there was also another type of slope field questions that they did where they like give you the slope field and then you have to go through like a particular point. So this example right here just had like a couple of points right here, and they asked you to draw the curves that would go through that point. And then if you remember, we were kind of like catching a current, like you were almost like doing a wave, like in a wave of some sort, like the stream or something, and you like try to follow the curve that goes through that coordinate. And they could have different answers depending on which coordinate it is. Another topic in this unit is approximating things using Euler's method. Now, I do love a good Euler's method question. We decided when we were taking these notes that it would be best to maybe do it in a table of information. It's not necessary to do a table. It's just really helpful. And so what you do is you start with your original coordinate. They give you this dy dx. Now, this one just has x plus y, but it could literally be anything, the dy dx. They always give you like a delta x that's given to you, and then you have to figure out the change in y, and you figure out the change in y by doing the dy dx value times the delta x value, and then you get your new coordinate right here. And then whatever is in this spot right here comes down and goes to the new table right here, kind of like a typewriter, bing, just, going over to the next guy. And then you guys don't even know what a typewriter is. I know I say this example every time, but you don't even know what it is, but you probably watched an old movie or something, and so you know. Okay, and so this would be handy. Just remember, guys, that this dy dx right here is given to you, and it's not necessarily x plus y. It's just, this is the one I snipped just as an example. Okay, what other fun things do they do in this unit? They like to do a separation of variables. When you do separation of variables, you're basically just sort of like sometimes they have like x's and y's sort of tangled up with each other as like a dy dx equals something. And then you would want to like move your y values over and just have dy with it, and then move that dx over to the other side, and then do the antiderivative of both sides. Just remember when you do these, you're doing your anti-differentiation, but remember there's only one plus c, and that plus c goes over on the right-hand side of the equation. So another one, sometimes when they do these initial conditions, just some notation to be aware of. Sometimes you'll have to solve for the plus C, right? So you'll have to do like an initial condition to solve for it. Not a problem. You guys are used to that. And then we had like some exponential models, right? So if you do exponential models with growth and decay, it's basically because there is some sort of a dy dx that is k times y. You will notice over here that there is no x value, or in this case, there would be no t values. And so what would happen is you would separate this y would go on this side, and it would end up being 1 over y. And then when you take the antiderivative, we're going to have to use some ln's. And then this dt would come over here, and you would end up having to do solving for C, and then you're going to end up with some sort of like an exponential equation. Yeah, I know that's tricky and fun. You'll have to practice those. And then there was the last idea of the logistic models, which we only do in BC, and AB they don't do. And so this BC topic is saying that if you get something that looks like this is kind of like a carrying capacity type question, right? We've had all sorts of logistic curves for the populations and such. And so it kind of like starts out looking like this and has this sort of pattern to it. For us, we may be more used to something that looks like this, okay, where we've got this carrying capacity. So we call the M value our carrying capacity right here. This K is some sort of a growth constant, or like a number that they give us. And then we were able to like take the differential equation, which has, of course, the dp dt in it. And then we were able to manipulate it over here to be just a regular population equation. Where you had to basically find what the A value was. The A value comes in by using the initial condition. It's the carrying capacity over the initial condition minus 1. And then all the little cute little numbers just kind of like fall into place. So very quick little review of things that are in chapter 7 and what you might encounter in your free response questions. So the ones that you are going to practice, you are going to practice 3 questions, just like always. You're going to put your journal entries in. You're going to score them. Again, guys, I'm not interested in what your score is. I just want to know that you are scoring it. A lot of times just looking at the answers and what they want is a good indication of how much you know, or the verbiage that you should have used, or maybe like, oh, I should have said it this way, or my answer was incomplete because I didn't include the units, or all that good jazz. So that is exactly what unit 7 is all about. So again, practice your FRQs, put it in the journal, come see me in office hours if you have a question, but really try to look at those answer documents and see if you can learn from those too. That is a tool that we're supposed to be using, and I think that's it. All right. I'm so glad we were able to be with each other today. I hope you have a lovely rest of your day practicing all your things, and let's go prep for this AP test. Bye, guys. See ya.